I set out to design this custom ESP32 enclosure as a personal challenge. I wanted to see if I could successfully translate concept from my imagination into a real finished product. I originally thought it would be a straightforward print, just sketching out an idea, sending it to the printer, and calling it a day. But 6 prototypes later, I've learned that dialing in the perfect tolerances is a journey. Let me show you how this evolved into a fully toolless design. The initial concept was inspired by a simple shoebox. I wanted a 2-part design, a main body to hold the board, and a sleek cover to slide over it. For this first prototype, I just wanted to establish the basic form factor and structural interaction. The main body featured a bottom hole for full access to the GPIO pins, and a front cutout for the USB ports. I also added a rear push access hole on the cover to make it easy to push the board out. And lastly, I printed it in white PLA. But once it was fully assembled, I immediately found my first major oversight. The cover body didn't have a matching hole at the bottom. The moment the pieces were put together, the GPIO pins became completely inaccessible. So back to the drawing board. For version 2, I added a hole at the bottom of the cover body so the GPIO pins were finally accessible. I also added some decorative holes on both sides just to improve the aesthetics, and resized the push hole at the back from tiny 4.6mm circle to a 14.8mm wide round rectangle. I printed the main body in white PLA and the cover in black PLA. But this is where I hit my first real wall with 3D printing tolerances. The clearance between the main body and the cover was excessively tight. When I forced them together, the plastic practically friction welded itself shut. To make matters worse, that newly expanded 14.8mm back hole was still too small for a finger to fit in. I literally had to use an external tool just to pry the enclosure back apart. I obviously needed a negative offset to loosen things up, but in version 3, I swung way too far in the opposite direction. I adjusted the clearances so the main body would easily slide inside the cover, but the fit ended up being far too loose. With just enough force, the main body would fall out of the cover purely by inertia. I also tried adding 2 top-down holes to the cover to give access to the ESP32's reset and boot buttons. Unfortunately, they didn't align with the actual buttons on the board at all. They needed to be offset closer to the USB port. On top of that, the cover body was actually obstructing the 5V and clock pins at the bottom. Version 4 was dedicated to fixing those usability issues. I finally enlarged the rear push access hole enough to comfortably accommodate any finger size. I got the top button holes properly aligned with the ESP32 and clear up the space around the 5V and clock pins. I even added grooves on the front bottom of the cover so you could slide the main body out while your Dupont wires remained attached. But the retention remained an ongoing challenge. The slide tolerances were still too loose, meaning the main body could dislodge from just a light push or inertia. And the ESP32 board itself was sitting so loosely inside the main body that it was prone to just falling out. Plus, the GPIO hole was still a bit too tight for the 3v3 and ground Dupont connectors. To stop things from falling apart, version 5 focused heavily on retention mechanisms. I introduced mechanical latches. I added a latch on the back of the main body to hold the ESP32 board in place and another latch on the front bottom of the cover to prevent the main body from accidentally sliding out. I also finally enlarged the GPIO pinhole clearance, making comfortable space for Dupont wires and accommodating any bent pins. It felt like a massive step forward, but getting the perfect snap is a delicate balance. That new board latch was still a bit too weak. If you held it at a slight angle, the board could still fall out. The internal clearance of the main body was simply too loose. It needed to be tightened to provide a better friction hold on the board, which would also help support that rear latch.
Let's go!
That brought me to the sixth and final iteration. I extend the rear latch on the main body and also tighten its clearance, successfully preventing the ESP32 from falling out any angle. I also tightened up the internal wall clearances to create a reliable friction fit that holds the board firmly in place. But I wanted to push this from a basic DIY box to a professional feeling product. As a final touch, instead of just leaving open holes for the buttons, I designed actual built-in mechanical button caps. You can now press the reset and buttons directly from the outside without needing to reach into the hose. It completes the transition to a fully functional toolless design. Getting to this final design took a lot of trial and error. Honestly, we see so many flawless 3D prints online, but the reality behind the scenes is usually a desk full of plastic scrap and tolerances that refuse to cooperate. Dialing in fractions of a millimeter is exhausting. It's a messy, frustrating process, but you just keep tweaking until it clicks. When you finally hear that perfect toolless snap, it makes the whole obsession worth it.